Elon Musk made an exciting announcement in a recent tweet where he shared a graph of a Raptor 3 static fire that lasted for 70 seconds. He congratulated the SpaceX propulsion team on achieving a chamber pressure of 350 bar, which translates to 269 tons of thrust. The SpaceX boss went on to mention that with the super heavy 33 Raptors, the thrust with the new Raptor 3 engines will be a whopping 8,877 tons, or 19.5 million pounds. That's almost 3 times the thrust of the Saturn V. Musk also mentioned that the team did not expect the engine to survive a full duration run at the pressure, and that it was uncharted territory. He also commented that the Raptor 3 chamber wall might have the highest heat flux of anything ever made. Hello Earthlings, welcome back to another video from the Cloud Boss. If you're interested in space exploration, tech innovations, space travel policies, and interstellar breakthroughs, you've come to the right channel. I focus on news and updates mainly from SpaceX and NASA. Please smash that like button and of course subscribe and hit that bell icon so you get the notification first the next time I upload a new video. SpaceX has developed a groundbreaking engine called the Raptor, which is essential for colonizing Mars. However, the Federal Aviation Administration has expressed concerns about the engine's power and potential to cause damage to launch pads. The Federal Aviation Administration and NASA feared that the immense strength of the Starship powered by the Raptor could destroy launch pads and potentially turn them into unusable wreckage. This has the potential to be a tragic setback for not only the Mars colonization project, but also for our broader dreams and aspirations in space. The Raptor 2 engine is a powerful force with a thrust of 510,000 pounds. Its power is compared to the famous F1 engine, which only generated 1.5 million pounds of thrust. However, when all 33 Raptor engines work together, they generate an incredible 16.7 million pounds of thrust during takeoff. This enormous first surpasses even the Saturn V rocket, which was powered by 5 F1 engines. The Raptor engine is already a powerful beast, but SpaceX goes even further by exploring the unknown potential pots of reusability. A reusable rocket engine is one that can be used not just once, but several times in a row. It sounds like a wonderful idea, right? But the way to achieve reusability is full of challenges and difficulties. Many people assume that reusable engines are cheaper. In fact, that's not true at all. The results of the shuttle program suggest that reusing space hardware is more expensive than building new ones, especially if the same certification standards are applied to both. The high cost of space hardware is the number and skill of workers that are needed to follow the traditional flight certification process and keep the launch on time and with minimal delays in case of a problem. Currently, SpaceX engineers are utilizing advanced scientific research. Nevertheless, even engines that cannot be used again are frequently tested for extended periods on stands during the development and certification processes. It is not rare for a solitary, non-usable engine to go through numerous test firings. Hence, the difficulty in producing a Raptor engine that lasts long and operates efficiently lies in its capability to withstand repeated use in harsh conditions. Moreover, a reusable engine such as the Raptor needs to have the capacity to restart, which adds more complications and chances of malfunctions. The design of the engine's bell must be able to endure the extremely high temperatures produced in the main chamber, which demands careful attention to materials and design. The engine operates on the limits of material capabilities, pushing boundaries while attempting to remain serviceable even after numerous start-stop cycles. However, the difficulties do not stop there. The area where the Raptor engine unleashes its true power, known as the combustion chamber, is subjected to extreme heat. It requires an incredible level of engineering skill to prevent the intense heat from causing the engine to melt. In order to overcome these challenges, SpaceX engineers are pushing the boundaries of scientific innovation to achieve thermal flexibility. Thus, SpaceX's Raptor 3.0 engines offer a glimmer of hope, possessing exceptional capabilities that could potentially take us to the farthest corners of our solar system. This represents a bold shift in SpaceX's aspirations, moving from simple launches on Earth to the grandeur of exploring other planets. Achieving greatness is not easy, and Raptor 3.0 has encountered many obstacles. Even SpaceX, which is determined to interplanetary travel, has faced failures. That's understandable because the road to success is often marked by failures, and the Starship prototypes have seen these tests. After experiencing testing setbacks, any mail reverberated throughout the SpaceX offices, calling committed staff to gather behind the Raptor engine line. Musk's message conveyed the sense of urgency, labeling the production circumstance a critical situation. He emphasized the high stakes and the imperative need to avoid failure. After the Starship's impressive display in space, the task of returning it from space safely arises. SpaceX has proposed using Mechazilla towers to catch it, but this idea has been met with doubt. In comparison, the Space Shuttle solid rocket boosters, SRBs, were labeled as reusable, softly landing in the ocean's embrace with the help of 3 beam parachutes. But the reality was much harsher. The SRB's doom was certain, its rear skirts brutally hitting the waters. Even when space pulls off the amazing task of successfully returning the Raptor engine to Earth, a difficult question emerges. How will a reused engine be approved for flight if the standards for flight approval are the same? As for a new engine, the reused engine must pass all the same tests from scratch overall. The process of testing a Raptor engine has been a test of determination, as there were problems with engines breaking down and encountering various issues. However, Elon Musk's determination is unwavering. The Raptor 3 engines used a technique that is rarely attempted, which is the full flow stage combustion engine, and they pushed the limits of what is achievable. In order to make the engines reusable, SpaceX has to be careful in recovering and landing them without adding too much weight. Compared to the Merlin vacuum engine, Raptor is more complex, more efficient, more than twice as powerful, experiences far more stress, and is 3 times younger from the start. Raptor 2, his purpose was to make future Raptors easier, faster, and cheaper to manufacture. In response, SpaceX strived to make Raptor 2 simpler wherever possible, removing a large part of the massa primary, secondary, and tertiary plumbing. Previously, Elon Musk confirmed that SpaceX had even removed a complex storage igniter system for Raptor 2, his main combustion chamber. As a result, Raptor 2, his production rate increased significantly. Despite those simplifications, Raptor 2 became 25% more powerful than Raptor 1 by sacrificing just 1% of Raptor 1's efficiency. Elon Musk had previously stated that they aimed to manufacture a Raptor engine every 12 hours by the end of 2019. But as is usually the case, that progress took far longer to realize. Despite that, in late 2022, a senior official from the NASA Artemis program disclosed that SpaceX had recently accomplished the sustained production of 1 Raptor 2 engine per day for a week. Such a high rate, likely making Raptor one of the fastest produced orbital-class rocket engines in history, is required because SpaceX's next-generation Starship rocket needs a huge amount of engines. The Starship upper stage currently requires 3 sea-level optimized Raptors and 3 vacuum-optimized Raptors, and SpaceX has plans to increase that to 9 engines total. Furthermore, Elon Musk stated that a new production plant will be built near the McGregor engine testing facility. He also emphasized it will be the highest output and most advanced rocket engine factory in the world. Currently, SpaceX's engine testing facility on 4,300 acres of land in McGregor, Texas, just south of the city of Waco, is undergoing new development and testing related to the Raptor engine. For Starship and Super Heavy, SpaceX's Raptor engines are a game changer for space exploration, especially for settling on Mars. That about wraps it up for today. Are you just as fascinated like me and want to learn more about the exciting discoveries in space exploration? tech innovations, space travel policies, and interstellar breakthroughs on a regular basis. Please smash that like button and, of course, subscribe and hit that bell icon so you get the notification first the next time I upload a new video. Thanks for watching and see you in the next video.